Hello and welcome to the third video in our Unity tutorial series. Before we begin, I have two things to note. First, I have upgraded my Unity editor to the 6.0 version, which means I'll be a little more up to date. Secondly, I've noticed from editing my videos that recording my voice and doing the computer recording at the same time led to subpar content. So from now on, I'm going to be doing them separately. But enough about video format. Let's take a deep dive into coding. You have seen components, which are pre-made behaviors, but if we want to make our own behavior, what we have to do is create a C# script. Now, if you watched my how to download Unity video, we already created one to make sure we downloaded the program correctly. However, I'm going to create a different one and put it in a specific folder for better organization. All we need to do is right-click to add a new folder, and I'm going to name mine Scripts. After that, you just need to right-click again and create a new mono-behavior script, naming it whatever you want. Just make sure, after you name it, the name of the file matches the name of the class. Now let's go jump in. When opening the file, you may notice a few things. The first few lines of code have the using command, which brings in some pre-made code for you to call on. These we will not touch much. Next part is called the class. Everything in these brackets defines the behavior of your script. Inside your class, you will see these pre-made methods called start and update, with brackets defining what runs in them. These are the main two things you'll be adding code to, and to see the difference between them, we're going to run this line in the start method and run it again in the update function. This line of code puts a message on your console when it is running, making it great for debugging your code. You can put anything you want in between these quotation marks, and that is the message it will put on the screen. To make our scripts run, we just need to save it and return back to the editor, where we need to add it as a component in our objects. But now, without further ado, let's see the difference between start and update. As you can see, start only runs once, while update runs continuously. What is happening is start is run once your object loads, and update is called every frame after start. There's an important note on how code is run. You can think of it as a recipe or a play script, which means it is read from one line to the next. For example, when I do these console logs, it will run, "Hi, how are you?" first, then, and "I'm a computer science major in finals week. How do you think I feel?" after that. Now, let's dive into the two most important features of programming. The first one being conditional statements. It starts with the if command. Then, if the item inside the parentheses is true, the code in the brackets is run. Otherwise, if it is false, it will not run. To make these actually useful, we can also check if two things are equal by using the double equal signs. In a similar vein, we can use less than and greater than operations. Do note that less than and greater than operations do not include when the numbers are equal, only when the value is greater than or less than. If we want to include that value, all we need to do is add an equal sign. The last operation is not equal, which is with an exclamation mark and an equal sign. These don't just work for numbers. They also work with words. However, only with equals and not equals. But an if statement is only half of our conditional statement, the other half being else if and else. An else if statement only runs when it is true and the statements above it are false. These statements can be made infinitely. However, if you want to catch all, the else statement always runs if the statements above it are false. Here's a few examples of the many ways these will run. But what if we want to check multiple different operations in one if statement? We can do that by using three different logical operators. The first one is easy. It is the not operator, which is an exclamation point. You can think of it as the opposite operator, with true things becoming false and false things becoming true. The next two things go hand in hand. They are the ands, which are two ampersands, and the ors, which are two vertical bars. A AND gate only works if both things are true, while a OR gate works so long as one thing is true. Now, before we're done with if statements, there is a shorthand I'd like to show you. If you have only one line of code to run in an if statement, you can run it without the parentheses. Now, on to the next pillar of programming, which are variables. There are five main types of variables: bools, which are either true or false; ints, which are whole numbers, both positive and negative; floats, which are numbers with decimal points; chars, which are one character; and finally strings, which are many characters. To create a variable, all we need to do is write either public or private, we'll get to what those mean later, then the type of variable we want to make, and finally, what we want to call our variable. Note, you can't have two variables with the same name. It is also good to be descriptive of what the variable means and not use single letter variables. To set a value to a variable, all we need to do is say equals the value we want. For chars, make sure the letter is in single quotations. For strings, make sure it is in double quotations. Note, after we have initialized the variable, we don't need to add the type it is. We only need to use the name. We can print the variable to the screen, and we can use them in place of our numbers in the if statements. Using this, we can see an example of how code is read like a script. First, we set x to 5, print the value, then we set it to 3 and print x again. What do you know? The console printed 5, then 3. I can also make two variables equal each other by having x equal y. Note, the order of this does matter. Whatever is on the left side is being set to the thing on the right. For example, in this equation, x equals 3 and y equals 5. However, once this line is run, both x and y equal 5. But setting variables to a value is not all you can do. You can also use math to make them equal new things. Plus for addition, minus for subtraction, asterisk for multiplication, slash for division. Note that division with floats is different than division with ints. If I were to do 5 divided by 2, with floats, I get 2.5 as expected, but with ints, it always drops the decimal point, so I get 2. There's also modulus with a percent sign, which returns the remainder of the division problem. So, for example, 4 divided by 2 divides evenly, so the answer is 0. However, 4 divided by 3 has 1 left over, so the result is 1. You can, of course, also put variables in place of numbers. There's also a couple of shorthands you can learn. For example, if I want to add 5 to x, I can write it as x equals x plus 5, or I can use x plus equals 5 for the same result. This works for all other operators as well. There's also another shorthand for adding and subtracting 1 from a variable. All you need to do is go x plus plus or minus minus for adding and subtracting 1 respectively. Now, we can also start variables inside our functions. This means placing them in the start or update functions, as those are the only functions we have right now. But what is the difference between placing them in the functions and placing them outside? Well, the main difference is that in the functions, variables can only be used by the function they're in and only last until the end of the function. This means that if the variable is in the update function, it will create the variable, delete it, then when it loops through it again, creates and deletes it again. This is opposed to the ones outside the functions, known as fields or member variables, which can be used in multiple functions and have their values persist. Another important detail is that the variables in the functions don't need to be public or private due to their nature, but member variables do. Now, what exactly do public and private do? Well, let's make two variables, one with the private keyword and one with the public. To see the difference, we're going to need to save our script and exit. Now, place the script on an object, and when you look in the inspector of that object, you'll see the parameters we can edit. You'll notice that the only one we can edit is the one that was public. However, if we just add serialized field to the private variable, we can get the same effect. So what really is the point? Well, if you create another script, you can edit and read public variables in another script. In order to do this, you're going to need to create a new type of variable, calling that component. So in summary, the purpose of the public keyword is so that other scripts can access it, while the private one is to prevent it from being used by other scripts. What if we wanted to make 100 different ints? We could make 100 different variables, or we could make something called an array. Think of an array as a list of a specific type of variable. For our example, that would be ints. To make an array, we just need to put square brackets on the variable type. To set the values, all we need to do is say the array is equal to the values we want to put in, separated by commas. Also, if our member variables are public or serialized, we can set them in the inspector as well. To get a specific value out, all we need to do is say the array name, square brackets, and the index of what we want to grab. The index is the spot we want to grab, so if we want to grab the first item in the array, we would want to put a 1. However, due to how computers work, lists actually start at 0. So to get the first item, we would need to actually put a 0. And if we want the second item, we need to put a 1, and so on. However, putting in the values manually can take a long time, so we can make code using loops to put in the values for us. The first thing we need to do is to define the size of the list by saying array equals new int square brackets and the length of the list. Now, what if we want to go through the entirety of our array? Well, we could use our update function to go through the list, adding to an index variable, then stopping when we hit the length of the array. Luckily, getting the length of an array is easy. All you have to do is array.length. However, going through a list this way takes a lot of time, as it only goes through one item per frame. And if you have an FPS of 50, it would take 2 seconds to go through a list of 100 items. So what if we could go through a list in only one frame? That's where our loops come in. The first loop to use is the while loop, which is shown here. These work by checking if the condition inside the parentheses is true, just like an if statement. The difference being, at the end of the brackets, it will go back up to the line with the while command and check if it is true or not again. Once the loop is done, the program will print the array. To show the difference in speed, here's the program both with and without the while loop. There is also another loop to go over, that being the for loop. The for loop is made entirely for the purpose of iterating. Here's an example of a for loop. The first parameter sets up a variable commonly named I. The next parameter is the condition. Just like the while loop, when this condition is true, it will continue to loop. Finally, the last parameter is the change at the end of the loop. What this does is change the variable at the end of every loop. Once the loop is done, the variable is then deleted. Overall, the for loop can be thought as a shorthand way to iterate through a list compared to a while loop. One last loop to learn is a variation of the for loop called a for each loop. The for each loop is for reading all the items in a list. Once again, here's an example of the loop. Note, in this loop, I have made an array of bools. First, we make a variable with the same type as our array variables, so a bool in this case. Next, we say in and our array name. What this does is set our variable equal to the first item in the array, in this case the value true. Then, once it loops back up, it sets the variable equal to the next item in the array, this one being false. It will continue to do this for the entirety of the array, then delete the variable. Now, two last notes on loops. It is possible to make a loop that never stops, so be careful, especially with while loops. Secondly, you can use the keyword break to exit one of your loops prematurely. Now, what if I want to do a bunch of lines of code? For example, printing this large message, and I wanted to do it multiple times, but not in a loop. This would be a perfect place to put a function. To make a function, we need to start outside of both the update and start functions. First thing we need to put is if we want it to be private or public. The next thing we want to put is what we want it to return. We'll go over returning later, but for now, we're going to put void to say this function returns nothing. Finally, we're going to put the name we want to call this function. The next step is putting the code we want to execute inside the function. In order to make our function run, just put our function name in either the update or the start, then put parentheses. What this does is run all the code in the function, then continues where it left off. Here's an example of this. Notice that our ending message is displayed after we did everything inside the function. Now, in terms of variables, the only ones we can bring in are the member variables, or the variables outside of all functions. However, if we do want to bring in a variable from another function, one thing you can do is create parameters. Parameters are variables we bring into a function to work with. To make one, all we need to do is make a variable inside our function's parentheses. I'm going to create two ints called x and y. Note, for multiple parameters, put commas between them. The goal of this new function is to print the sum of x and y. Now, we call the function in the same way, but now we add two numbers as our parameters. A thing to note is that you can call functions from other functions, like we did with start and update, but you can also call it from itself. This is known as recursion. And here's an example. This function will count down from the number it receives until it reaches 1. At that point, it will stop. So if I call it in the start function and put in the number 10, it will count down from 10 and stop at 1. Be careful, however, as if you do accidentally make an infinite loop, you'll get an error known as a stack overflow. Next, let's go over function returns. We can have a function return a variable after it is done. Its type denoted where we have been placing void. As a reminder, void means we are not returning anything, but we can use the return keyword to end the function early. For other types, like ints, the function will return whatever value you place in the return. Here's an example of this in action. Here we have a function that adds 1 to the parameter put into it and returns that value. In the start function, we are taking our print command and putting the function in it, and it will print the result of the function. Going back to the private and public keywords, you can call functions from other scripts if they're public, the same way we called variables, but this time with the function syntax. Overall, functions are like little blueprints for your code, and if you make good functions, you can make your code a little more readable. Let's put everything we know together and make a little Flappy cube. First, we're going to make our cube, adding a rigid body and a box collider. Now, I'm going to make a new script, and I'm going to call it the creative name Flappy Cube. The first thing we're going to do is make a reference to our rigid body. Then, we are going to get some inputs from the user. To do this, we need to make an if statement with input.getKey. And we're going to put the key we want to detect in the parentheses. We do this with keycode.the key we want to detect. In this case, I'm going to put NA. I'll also make an else if statement for the D key. Then make an else statement. I will also make a new if statement detecting if the space key is pressed. But I'll change the get key to get key down so the code does not continue to run if the space key is held. Now we will change the velocity in our if statements by setting rigid body dot velocity equal to a new vector with how we want the objects to move. Here are the values I have set in the vectors. The first value on the vector determines how fast it moves on the x-axis. The second determines how fast it moves on the y-axis. You will also notice that the vectors use a velocity variable from rigid body. What this variable means is that it should move the same speed that it was already going. If we were to just put a 0, then it would cause the object to stay in place. Once we have done all of this, we can play with our cube and use the A, D, and space keys to move. The last thing I want to mention is comments. Comments are like little notes you leave for yourself to better understand what some code does. They are ignored by the computer, so they don't actually affect your code. To make one, just put 2 slashes in a row. Then everything after it on the line is part of your comment. If you want to make a multi-line comment, just / star at the beginning, then star / at the end. There you have it, an introduction to scripting in Unity. Now, I'm going to be a little honest here. I don't know everything about Unity. I also don't know how Unity developers like to format their code. But you don't need to know everything about Unity to be a good Unity developer. You also don't need to learn how the industry formats their code, though there are reasons to do that, organization being one. But what I do encourage you to do is practice on your own. Practice making a script. Make a script that I didn't do. Make a script on your own that may rotate an object very fast across the screen. Something like that. Something to practice to help you get a little more used to scripting in Unity. But anyways, that's all for now. Signing off.